Hello everyone, welcome to Code with Raj. So today we would be solving next question from our top interview 150 series. Today's question is rotate array. So this is a very interesting question. Let us read the question and understand what does it say. Given an integer array nums, rotate the array to the right by k steps where k is a non-negative, where k is non-negative. Example, the example is given. Okay, so and the constraints are given k less than 10 power 5, etc. Okay, so let us try to understand the question and make a suitable approach for this. So basically, what we are doing is let's take the first sample test case only. We are given a nums vector 1, 2, 3, 4, 5, 6, 7, and k is equals to 3. Okay, so now it is asking that we need to rotate the array from the end. So this 7 will come here. So in the next in the when k will be equals to 1, it would become 7, 1, 2, 3, 4, 5, 6. Basically this k jumped over here, and at k equals to 2 it would become, now 6 will jump over here. So 6, 7, 1, 2, 3, 4, 5, and at k is equals to 3, 5 will jump over here. So it would become 5, 6, 7, 1, 2, 3, 4, and we have to return this array. We need to do everything in place. So for reversing the array, what is the most basic approach you could think of? Like, since we are just using our last element and returning it every time, so like what we could do is each time we could update our nums vector to do this, है ना? Like when we are traversing, like we always take the last element and append it to the first and do nums dot pop back for in one iteration. Like in one iteration, what we are doing is take the last element arr dot back, store it somewhere, and then pop the element arr dot pop, and then append it at the starting of the array. So to append at starting, you can use arr dot insert. You need to insert at arr dot begin, and what is the value? X. So in each iteration you can do this. So this loop will run for big O of k, but inside we are doing this operations take big O of n. So big O of k into n. So this is not a very good approach because the time complexity is too much. So we need to have something so that we can optimize this time complexity in order because this won't get accepted on this because the nums dot length is around 10 power 5 and k is also around 10 power 5. So 10 power 5 into 10 power 5 is roughly around 10 power 10. So this won't pass the custom test. So let us try to build a different approach. Okay, so again coming back to the example, this is our approach 2. We have 1, 2, 3, 4, 5, 6, 7, k is equals to 3. So like we could think of something different. Like at the end this array is just rotated and elements are coming from back to front. So what we could do is we could like make an array like this. We could append this whole array again back to itself only. 1, 2, 3, 4, 5, 6, 7. So you can see now we need to find our answer 5, 6, 7, 1, 2, 3, 4. It is here only if you observe it carefully. And after how many position it is coming? 1, 2, 3, 4, which is basically our n minus kth position. So this is a very better approach from previous one, as what we are doing is we are appending the array. So it would take big of n time complexity, and then we are using another pass to copy these elements into our nums vector. So we will create a temporary array for this, and at last we would copy these all in our nums vector. So big of n for copying. So roughly time complexity would be big of n, but we would be using a big of 2n extra space for holding the stem vector. So this approach is far better from that approach, but still we are using this big O of 2 and extra space, and we could still optimize this approach because we could do it in like big O of 1 also if you try to think more, because there is a subtle observation that you need to see so that you can solve this question. Okay, so this was our approach 2. I hope you understand this approach. Now let us move on to the most optimized approach, where we would be using big of one space only and doing everything in place in nums only. Okay, so let me give you an observation. again coming back to this 1, 2, 3, 4, 5, 6, 7. Okay. And one more thing I forgot to tell you. Basically, if k is greater than n, for example, our n was equals to 6, but our k is given to be 100. So what you think we should do? We should do that rotation 100 times and at last we should check what is the answer? No. Because you see, 1, 2, 3. If this array is given and k is equals to 4, let us try simulating this. So 3, 1, 2 and then 2, 3, 1 and after that 1, 2, 3. So at every third position, we are again getting back the same array. I think you understand what I'm saying. So we need to do k is equals to k modulo n. So if k is 6, if k is 4 and the array size is 3, so k is equals to 4 modulo 3, which is 1. So our output should be this only, because after this we would get this only 2, 3, 1. This is our answer. So instead we could got it earlier. So k should always be less than equal to n. Okay, so let us move on to the final approach. This was very important to explain before our final approach. So like I want you to observe one thing very quickly. I will do some operation and you need to see that whether we got a desired answer or not. So this is our array. Okay, and it is saying that we need to do this for k step. K is equals to 3 in this case. So let us take these four elements. You see that these four are directly shifting away here. Okay, at the answer, these four are directly shifting here. You can see. So let us do one thing. Let us reverse this whole part. 4, 3, 2, 1. And let us reverse this whole part. 7, 6, 5. So reverse this whole part. Now let us reverse the whole array. 5, 6, 7, 1, 2, 3, 4. Can you see something? Yeah, you can see that this is exactly what we want. So why this is working? So like see, you want 1, 2, 3, 4 same as it is here, but to bring 4 here, either you shift these or you swap. So if 4 will come here and we reverse the whole array, this would get swapped here immediately. And we are doing this at particularly n minus kth index only, so that we get our desired answer. And here also, like 5, 6, 7, this has to be moved immediately here. Uh, yeah, so okay, let us take this color. Hmm. So this 5, 6, 7 has to be moved immediately here. So that's why we reverse this, and at last when we again perform the reverse operation, all these elements get swapped to their respective position. So this is the most optimized way. As for the first reversal, since we are doing it on the whole array, we are using big of n time, and for the second reversal we are again using big of n time. So big of 2n time, which is roughly big of n only. So big of n time complexity and big of 1 space complexity. So this is the most optimized solution that you can answer. If this question comes to comes in an interview, the interview would be happy to accept this solution only, because our approach 1 and approach 2 like was slightly more time taking considering this approach. So this is our best and most optimized approach. So let us come onto the code editor and try to code it once. Okay, so first let's int n is equals to nums dot size, and then we need to do k is equals to k mod n, because we do not want to have extra iterations. Okay, so now what we do is we call the reverse function, reverse nums dot begin comma nums dot begin plus n minus k, because we need to do till n minus kth index only. And then we call the reverse function again, n minus k, and now we need to do this till the end of the array, because rest of the elements we need to reverse ultimately. Nums dot end, and at last we just reverse the whole array. Nums dot end, yeah, and at last we just return, because it's a void function, no need to return anything. Let us run it on the sample test cases. I hope it works fine. Yeah, so you can see this is getting accepted. For debugging purposes, let's print once the array. So instead we make a function void p vector int error, and what this will do is and let us call this function. So you can see that what are the changes that we are making in our array. Nums, we will print first here, then here, then here, and at last. So you can see four times, one without change, one with first reversal, one with second reversal, and one with the third reversal. So you saw that first of all we had the normal array, then we reversed the first four bits, I mean first four indexes, and in the second case we reverse the last three, basically the k, from n minus k to k elements more, and at last we reverse the whole array and we got our final output. So let us comment these and submit the solution. So our solution got accepted. I hope you liked my approach. Please make sure to press the like and subscribe button. And I would love to hear your feedback in the comment section. And the code link would be available soon in the description. Thank you so much for watching. Bye bye.